Hi class. Hi class. So today we're going to learn about integration by parts. Okay, integration by parts is there is the formula for integration by parts which you must memorize, which is the integration of u dv is equal to uv minus integration of v du. I know it doesn't make sense yet, so we're going to look at the examples. But first, there is a rule. Let's say we have this function x cos x, and we must transform it to be into this form. So, which one is u? Which one should we choose as u, and which one should we choose as dv? Okay, what is the rule? Okay, rule number 1 is to choose dv, the one that is simple to integrate without using integration by parts. Okay, and u is whatever the leftover part lah. Okay, I think rule number 1 might be a bit confusing, so we better choose rule number 2. So rule number 2 wants us to choose u in this order, where this is 1 2 3 4 5. So the number 1 that tops the rule, if there is a log function in the equation, choose that one first. Okay, and so it goes along this order. So looking at this, x cos x dx. Okay, which one should you choose first? Okay, this is a multiplication of two functions, which is x and cos x. So x is algebraic function, and cos x is trig function. So which one should we choose as u? And u should be what, guys? U should be algebraic function, which is x, and dv is the leftover part. What is the leftover part? The leftover part is cos x. Okay, I hope you can get this by now. Okay, now we have choose u and dv. So we want to complete this equation. Not to complete, to solve this equation, we must use this formula. Okay, uv minus the integration of v du. So now we know u and we know dv, but we don't know yet what is v and du. Du is du dx, right? Okay, so du dx for this one is what? 1, right? Where du is equal to dx, and v is the integration of cos x dx. Where you integrate cos x, you will get sin x. Okay, I think I wrote this down just to make you familiar how to choose u and how to proceed from that step. Okay, now let's do it here. Okay, so now we have this blank slide, so it will be better for you to see. We have this equation here, x cos x dx, and to solve this, we must use integration by part. So what is the formula for integration by part? Okay, the formula for integration by part is the integration of dv equal to u dv equal to uv minus the integration of v du. Okay, as we have solved earlier, u is x and dv is cos x dx. How do we choose which one is u and which one is dv? Okay, we choose that according to this list. Okay, so according to this list, algebraic function is on the third and trig function is on the fourth. So we choose u to be x and cos x to be the dv. Okay, that's how we choose. Okay, and then we want to know what is du. Dx is 1, where du equal to dx. Okay, we need the term du to slot into this equation later on. Okay, and to find v, we have to integrate cos x dx. So integrate cos x, you will get sin x. Okay, so now that's settled. And okay, wait okay, never mind that. Okay, so should be uv v du. So uv is u is x and v is sin x minus the integration of sin x and du is dx. Okay, that's all. Okay, I forgot to turn on the record button again. Okay, guys. Okay, I think I stop at this part here. So this equation can be rewritten like this: x sin x, and you integrate sin x, you will get minus cos x plus c, and this is the final answer for this equation here. Okay, so that is how you solve equation using integration by parts. The most important thing is for you to understand this part here, and also of course to memorize this formula. Okay, so now for your better understanding, we're going to look at another examples. So we're doing example 10, part of example 10 anyway. So example 10, A is the integration of ln x dx, which can be rewritten like this, right? 1 ln x dx. Okay, so looking at 1 and ln x, which one should you choose as u? Okay, cannot remember, it's okay. We can look back at the list. So okay, the one that tops the order is ln function. If there is a ln function in the equation, choose ln function first to be u. Okay, so we choose u ln x, and du dx is 1 over x, where du is what, guys? Du is dx over x. Okay, and then what is dv? dv is 1, where you integrate 1 dx. dv is 1 dx. Okay, and you integrate 1 dx, you will get x. Okay, and slot that into this equation here. So uv minus with the integration of v du. So uv is ln x. Okay, it's better to write it like this, or if we get it will not be okay lah. Okay, so x ln x uv minus the integration of v. What is du? du is dx over x. So x here can be cancelled out together, right? So you will get x ln x. Okay, integrate dx, which is 1 here, you will get x ln x integrate 1, you will get x plus c. So this is the final answer for A. Okay, now we want to try to solve B. Okay, I don't want to pause yet, or I will risk not remembering to turn on the record button again. Okay, so B is the integration of x square ex dx. So we can see there is the exponential function here. There is exponential function. Okay, and this is the algebraic function. Okay, which one should we choose as u? Not sure? It's okay. We can look back at the list. Okay, algebraic function. Okay, sorry, exponential function is at the bottom. So algebraic function is number 3. So we shall choose the algebraic function to be u. Okay, so u is x square, where du dx is 2x and dx is 2x dx. Okay, and dv is what, guys? e to the power of x, and v is ex. Okay, don't forget dx here. Okay, dx. Okay, integrate ex, you will get ex back, right? Okay, and put this into this equation. So uv is x square times with ex minus the integration of ex, and du is, sorry, this is not okay. Okay, and du is 2x dx. So how do we do this? 2 can be put outside, right? So now you have this. Okay, what do we have here? What do we have here? So we have to do another integration by parts, right? Integration by parts again. Okay, so which one should be u? U is x, because obviously this exponential function is at the bottom of the list, right? We just take a look at the list just now. So dv is ex dx, and du is equal to dx is equal to dx is equal to 1, and du is equal to dx. Okay, and v, when you integrate ex dx, you will get ex back. Okay, x back. Okay, so now x squared ex minus 2, and what do we do now? Okay. Okay, so the formula for this is uv, so uv here, there's no square, right? X ex, and the integration of v du. The integration of v du, what you will get here is the integration of v du. Okay, so ex du is dx, so integrate ex, you will get ex back, right? Okay, I hope you can get this. Where should I write it? Okay, I think, okay, I hope you will get this. Okay, so x square ex minus 2 x ex minus this one. Okay, so that is how you solve example b. Okay, I hope you can get this. I really do. Okay, if you have any question, please do not hesitate to contact me. Okay. Okay, just to recap, this part here you have to do integration by parts again, where we choose u to be x because it is algebraic function which is number 3 on the list, and dv is e to the power of x dx. Okay, to get v we must integrate dv, where you integrate ex you will get ex back. Okay, and you differentiate du dx, you will get 1, and du equal to dx, and slot it back into this equation here. So u is x and v is e to the power of x minus the integration of v du. So v is the integration of ex du equal to dx, and you integrate this, you will get e to the power of x, which is shown in this result here. Okay, so now moving on to the next question. Okay, so questions C I will let you know later. However, for D, I want you to do this at home. X e to the power of minus x dx, and the answer should be 1 minus 5e minus 4. Okay, where the hint is you must differentiate e minus x dx, you will get, okay, remember when you integrate e to the power of minus x, you will get the same thing, right? Okay, you integrate, let's see here, integrate ex, you will get ex back, right? So same thing here, you will get you differentiate e minus x, you will get e minus x. However, there is a minus one function here, so it's minus 1, because this is in actual is ex to the power of minus 1 power. Same thing, when you integrate e to the power of 3x, you will get e to the power of 3x along with this value here. Okay, please remember this. Okay guys, and that's all for today's lecture. Okay, bye.